We left off at the end of the last video with the conclusion that the fundamental algorithm of the brain is trying to minimize surprise about the world. This is what the free energy principle proposes, and there are a lot of neuroscientists that generally agree with this theory of how the brain works. We could call it surprise or we can call it uncertainty, but the free energy principle proposes that the fundamental algorithm of the brain is optimizing to reduce uncertainty as much as possible. So we have our prediction machine, our generative model, and our objective function. Now what? How does the brain actually reduce surprise in its environment? This video will present what the free energy principle proposes the brain uses as the fundamental algorithm. Let's return to my favourite example at the moment, that brain floating in a box in a dark room. In this scenario, the brain has a bunch of inputs coming from its sensory receptors. At any point, it's generating a model about what it thinks might be causing those signals in the surrounding environment. But that generative model is a guess, and sometimes the brain will be wrong. Sometimes there will be an error in the prediction, also called a prediction error. But what should the brain do when there is a prediction error? The bigger the prediction error, the bigger the surprise. And we know that the brain wants to minimize surprise. So we know that the brain needs to reduce that prediction error, but we don't know how. Well, the brain doesn't have loads of options to choose from. The available options in its range of outputs can generally be grouped into two choices. Either I can change my belief about the world, or I can take action to change my world for the brain to reduce surprise. It can either change how it thinks about the world, or it can change its world. I'm not sure if this is obvious to people, so we're going to go through some examples. Imagine being in a rainforest and suddenly seeing a tiger walk towards you. Instinctively, you're probably going to be surprised to see that tiger. If your fight or flight response is really strong, you might even immediately bolt upright and run away. If you did run away, or that was what you imagined you would do in this situation, that would be an example of your brain choosing to update its actions. But let's imagine that you're not by yourself when you see the tiger and you're actually on a safari trip. In the safari context, although you are surprised to see the tiger initially, your brain is going to update its beliefs about the world to something like, the purpose of safari is to see wild animals like tigers. I am protected by the professional rangers here with me. This way, the brain changes its own model of the world so that the tiger is predicted and the human feels safe. But it's not every day we're on safari seeing tigers, so maybe let's try a more everyday example. Imagine that you're in a crowded bar and you think you've seen an old friend on the other side of the room. You haven't seen this friend in years. They don't live in this area, and so you're not expecting to see them. But you're not entirely sure it's them because they are quite far away. What do you do? Well, again, your brain basically has two choices. In this instance, you can either update your belief about the world and say, it's probably not the person I know, or you can update your actions and walk over to say hi. In this example, you may walk over and the person isn't someone you know, in which case your brain then has certainty that the person is not their friend. Alternatively, if it does end up being someone you know, then the brain knows to update its world model in future to expect to see this friend in this bar. Although the tiger example and the social example are quite different, and on the surface the brain has to choose between quite different options, what all the options have in common is that they ultimately reduce surprise in the brain's model. The technical terms for what we just went through are optimal inference and active inference. When the brain reduces surprise by updating its beliefs, that is called optimal inference. And when the brain reduces surprise by changing its actions, that is called active inference. And that's the theory of the free energy principle. The theory proposes that the brain is always trying to reduce surprise, and the only ways it can do that is either by updating its beliefs about the world or by acting on the world to change it. One open question in the field, which I find particularly interesting, is what actually determines whether the brain chooses to update its beliefs or update its actions. A normative perspective might say that updating beliefs, changing the generative model the brain has about the world, is going to be more expensive and time-consuming than taking action in the world, so the brain is likely to update its actions before updating its beliefs. But this has not been proven empirically and is a difficult question to test. I will go into the idea of Bayesian inference and the Bayesian brain in more detail in a future video. And I will also do a video on how these Bayesian models can be applied to different mental health conditions to help us better understand them. It's important to emphasize that this is one theory for how the brain works, originally published by Carl Friston. This video has provided a summary of one part of the theory, and the main references for this theory can be found at the end of this video. The theory explains a lot of data across many fields, but it is only a theory, and there are many different ways the theory can be critiqued. If you have issues with this theory, like potential critiques, or you have feedback about anything that I might have missed in this video, or ideas you want to see more of, then drop me a message in the comments below. Thanks very much for listening.